Let's go ahead and do a couple of examples of using this with numbers. So let's say that I give you a triangle. And when we say we want to solve a right triangle, this might be a left column idea you might want to write down. When we solve a right triangle, it means that we find the values of all three sides and we find the values of all three angles. Okay. So for example, with our first problem, I'm going to give you here's little a, little b, little c, big A, big B, big C. Pretend as a big C. All right, fine. Don't pretend. All right. So let's say little a is 2, and let's say B is 60 degrees, and C is 90 degrees. I want you to go ahead and find me the values of big A, little b, and little c. Let's go ahead and draw a picture. Here's big C, it's 90 degrees. Here's big B, which is 60. Here's A. Boy, that's sloppy. Let's see, this is going to be little b. This is going to be little a, which is 2. And this is little c. Regardless of how you perform the geometry, you should know by now that the sum of the interior angles of a triangle is equal to 180. This is called the triangle sum theorem. Okay? So in other words, this 90 degree plus this 60 degree plus this mystery angle equals 180 degrees total. So with that being said, we should know that A plus B plus C is 180. Notice I'm using the capital letters, not the sides. This will never work for the sides. I know that B is 60, C is 90. I know some of you already got this done a long time ago. I'm just showing for those of our classmates who maybe didn't do too well in geometry. So if we add these up, 60 and 90 is going to give us 150. You subtract 150 from both sides. You get A is equal to 30 degrees. Maybe some of you caught on early on that this is a 30, 60, 90. I need a better eraser. E, E. Wow. Okay. All right. Excuse me. So we have the angles. Great. Now we need to figure out the two sides. This becomes very interesting. This is where you got to start thinking. Okay. My question to you is, what do you want to get next? Either B or C, right? So let me go ahead and label what I have. I have now 30 degrees up here, right? Inside. Notice when I draw the angles, I draw them in the inside corners. Sides go outside of the side. Don't ever put the sides on the inside, you'll confuse yourself. So here's where the trigonometry comes in and becomes very useful. We have these relationships. You see how if I'm standing on a certain corner, I can set up a relationship between two different sides. Okay, but you have to pick the side that you necessarily need. So for example, if I wanted to find, let me change a different color here. If I wanted to find the hypotenuse, little c, you'll notice that if I use tangent, it wouldn't help because tangent only compares A and B. It doesn't involve C at all. Okay? So tangent would not be useful. However, if I wanted to use sine or cosine, those both have C. Okay? But the question then becomes further, well, which one can I use or does it matter? What did they give you? They only gave you A. So if they gave me A, little a, and I want to find little c, I would have to use I would have to use either this one or this one. And the only difference is it depends on what corner you stand on. Do you want to stand on corner A or do you want to stand on corner B? Okay. Either way, good news is if as long as you set them upright, it'll give you the same exact answer. Okay. But the difficulty of doing this is you have to know what you've been given and how you're going to use them. So in this case, I'm going to stand on corner A. Okay, I'm going to stand on corner A, and I'm going to set up sine. Sine of, sorry. I'm not going to do sine of A. I'm going to do sine of the actual number, 30. It's going to be the opposite, which is 2, over the hypotenuse, which is C, and that's what I'm looking for. Now, because what we're looking for is in the denominator, okay, it's going to be a bit tricky. I would suggest the following. If what you're looking for is in the denominator, I want you to go ahead and just switch it with this. So in other words, it's going to be C equals 2 over sine 30. And the reason for that is you put it over 1, you do your cross multiplying because of its a proportion. A proportion is a comparison between two ratios. And then you go ahead and divide and you end up with this. Okay. So you get little c is 2 over sine 30. Let's put this in a calculator. And we'll go ahead and turn it on. Let's first make sure that you're in degree mode for now. So you're going to go to mode. And you're going to see it's in radian mode, so I want to go to degree mode. I have to move this button. Hit enter. Now we're in degree mode. I'm going to go ahead and quit by pushing the blue button and the quit button. And I'm going to go ahead and type this in. 2 divided by parenthesis sine 30 close parenthesis close parenthesis. And I get that the answer is 4. So little c is 4. So take note, maybe if you want to pause and think about how the heck I did that, maybe replay it if you need to, maybe try it out again to see if you can get the same response. It wouldn't be a bad idea. Okay, let's do let's find little b. So to find little b, see if I can. Okay, to find little b, I'm gonna go ahead and say on the same corner. Okay, but this time I have a lot of options. I have A and I have C, and I want B. I want B. So I could either use cosine, right? Or I could use tangent to get B because I have both A and C. I'm going to suggest cosine. Okay? You can get the same answer either way. So cosine, don't put angle A, put the 30, the actual value of it, is equal to the adjacent, little b, over the hypotenuse, which is 4. You're going to notice that this time, your variable is not in the denominator. So if it is in the denominator, that's when you do the switch and you end up dividing. This time it's up here in the numerator. You're going to multiply both sides by 4. So remember, if your variable is in the denominator, you will divide. If your variable is in the numerator, you will multiply. Let's go ahead and put this in the calculator. 4 times cosine 30. And it's a decimal value. We can make it be, oops, where did it go? We could be 3.464 would be fine with me. Okay. So we have solved for this triangle. We found all three sides and we found all three angles. This triangle is completely solved. Good job. Let's go ahead and try another one. And I'm sorry if we ran out of space. Maybe I should write smaller. Okay, let's try. 1a is 3, b is 3, c equals we don't know what, a is we don't know, b is we don't know, c is 90. So step one, draw the right triangle. You'll notice that the two sides, the adjacent and the opposites, are going to be identical. So this is going to look like an isosceles triangle. Ah, snap. This is going to be 90. This is capital C, A, B. So little a will be 3, little b will be 3, and then here's little c. You can't use the trick A, B, C equals 180 because we are missing 2. Okay. You'll know that A plus B is 90 degrees at the end because if these two are complementary and you add them to 90, then you get the 180. So, well, what can we do? Let me suggest the following. Since I have two sides, I want to go ahead and find out an angle. Let's find out one of the angles. So, what trigonometric ratio has both A and B? I'm going to set up tangent. It's tangent of A, okay? So I'm going to set up tangent of A equals 3 over 3. But Miss Rover, you forgot to put the angle in. Bruh, we don't got the angle. We're finding the angle, okay? So that's why I left it as an A. We're going to find the angle. Well, we can simplify this further because 3 over 3 is 1, right? All right, this is going to be special and different than last problem. In order to find the angle, we have to do what's called an inverse function. Okay, so if you recall from algebra 2, inverses, functions. So for example, if I have a function, this is just a side idea. If you have a function and it's f of x, then the inverse of that function is going to be f negative 1x. The inverse is when you go ahead and change the x for the y value. Okay, and so you have a mirror image on the graph. When you did exponential functions, the inverses of those were logarithmic functions. And if you don't remember, we'll do some more of those in this class. All right. So in order to get the angle by itself, I'm going to do what's called an inverse tangent. So essentially, what I'm going to be doing is the following. I'm pretty much going to multiply this by tan negative 1. And I'm going to do this tan negative 1. And what happens is the tangents cancel out, and I'm left with A equals tangent negative 1 of 1. Right? This is why we're doing this, because sometimes people just freak out about this stuff. So we only do the inverse. This is the inverse operation. The negative 1 is inverse only when we need to get the angle by itself, the capital letter by itself. Looking at our calculadora, to do this, I have, you notice I hear sine, cosine, and tangent. But if you look above in blue, there's the inverse sine, inverse cosine, and inverse tangent. So I'm going to do this, the blue button first, and then do the tangent. Notice that it gave you the inverse tangent, and then I'm going to type in that 1, and then close it. and this is the angle. It's a 45-degree angle. Now, those of you that are sharp on your geometry, you would have automatically caught this and said, oh yeah, it's a 45, 45, 90. Boom, it is. Okay, so A is 45 degrees, and therefore B is 45 degrees. Noise. But we're not done solving this right triangle because we're going to find the value of little c. All right, let's find the value of little c. If you want to pause and find the value of little c and then see if you get the same value, go ahead and pause me. Get little c. Pause. Okay, let's see what you got. So I'm going to go ahead and do this just for kicks. I'm going to go ahead and do this a different way than you did it, most likely. I'm going to go ahead and set up. I'm going to set up from here, and I'm going to do sine of B. Okay, so sine of B will be the opposite over the hypotenuse. So in this case, it'll be sine 45 is equal to 3 over c. It's probably the same thing you got anyway. Notice that the variable is in the denominator. So if it's in the denominator, you're going to divide. Don't forget those parentheses. 4.242 or something like that. 4.24. Notice that we solved for all three sides. We solved for all three angles. This right triangle is solved. Take some time to write some summaries, and now that everything is still fresh, to talk about some of these things. Cool beans.